Somewhere in your house right now, there's a part that costs less than your dinner tonight, and it might be the only thing standing between your air conditioner and a $5,000 repair bill. Nobody installs it unless they ask. Most people never ask. By the time you finish this video, you'll know exactly what it is, why it matters, and why the guy who serviced your AC last summer probably walked right past it. Here's the problem nobody explains properly. Every time your air conditioner switches on, the compressor, the part actually doing the cooling, has to jump from a dead stop to full speed in a couple of seconds. To do that, it doesn't just draw a little extra power. It pulls 4 to 8 times its normal running current just for that first moment. On a hot day, that startup can happen 6, 7, 8 times an hour. Every single one of those moments puts a jolt of heat and stress through the compressor and the wiring around it. Do that thousands of times over a few summers, and you're not looking at routine wear anymore. You're looking at the most expensive failure in the entire system. Most homeowners never connect any of this to a cause. They just notice the lights flicker for a second when the AC kicks in, or the breaker trips out of nowhere, or there's a stuttering click before the unit finally catches. They shrug it off. It's not nothing. It's your electrical system visibly struggling under that surge every time it happens. Here's the part almost nobody walks you through. This problem was solved decades ago, and the fix has been sitting in HVAC supply catalogs the entire time. It's called a hard start kit, sometimes sold as a compressor saver. It's not new technology, it's not experimental. It's been standard equipment on commercial refrigeration and rooftop units for years. It just rarely makes it into a residential service call, unless you specifically ask for it. To understand why it works, you need to understand what your compressor is actually fighting against when it starts. Engineers call it a high inertia load. Basically, a heavy motor that has to physically overcome its own resistance to get moving from a standstill. That first push takes far more energy than keeping something already spinning in motion. Your AC has a run capacitor that's excellent at keeping the compressor going smoothly once it's up to speed. Think of it as a great marathon runner. But a marathon runner isn't built to sprint out of the blocks. That explosive first push was never really its job. A hard start kit adds a second capacitor built specifically for that sprint. It sits quietly charging between cycles, and the instant the compressor gets the signal to start, it releases a burst of stored energy that helps the motor spin up in a fraction of the time. A relay then disconnects it the moment the compressor is running normally, so it isn't doing anything the rest of the cycle. It's just standing by for the next start. That one job, done well, can cut startup time dramatically and take a serious amount of stress off the compressor with every cycle. Now, about the money. And I want to be straight with you here, because a lot of videos on this topic oversell it. You'll see claims floating around that a hard start kit will visibly shrink your electricity bill every month. In reality, that startup surge lasts a second or two out of an entire cooling cycle, so its actual effect on your total power usage over a month is small. If a video promises you're going to see a dramatic drop in your utility bill, be skeptical. The real payoff is somewhere else, and it's arguably bigger: compressor protection. A compressor replacement runs $2,500 to $6,500. A hard start kit installed by a licensed technician typically lands somewhere between $70 and $200 total. If it buys your compressor even 2 or 3 extra years of life, that's a lopsided trade in your favor. You're just not going to see it as a monthly number on your power bill. So why doesn't this come up more? It's not some grand industry conspiracy. It's simpler than that. There's no real incentive built around recommending a 30-minute job on a $30 part when the alternative conversation is a full system replacement worth thousands. A technician isn't lying to you by not mentioning it. It's just not the path of least resistance in that conversation, and most homeowners don't know to bring it up first. This shows up constantly in property management and multifamily housing, where maintenance techs deal with dozens of aging units every summer. Rather than replacing a struggling compressor outright, a lot of them install a hard start kit as standard practice on any unit showing early startup strain. It's cheap insurance against an emergency call-out in the middle of a heat wave. If you want to know whether this applies to your system, here's how to check it yourself, in plain terms. Watch a light in the same room or on the same electrical circuit as your outdoor unit. If it visibly dims the moment the AC kicks on, that's your system telling you something. If your breaker has tripped when the AC starts even once, that's a second sign. A clicking or stuttering sound right at startup is a third. And if your electricity bill has been quietly climbing over the past few summers with no real change in how you use the AC, an aging compressor working harder at every startup could be part of the story. If 2 or more of these sound familiar, it's worth calling an HVAC technician and asking directly whether your system is hard starting and whether a hard start kit makes sense for your unit specifically. A word of honesty on the limits here: this isn't a fix for every situation. If your system is more than 15 years old and already failing internally rather than just struggling to start, a hard start kit won't undo real internal damage. It just gets a dying compressor moving temporarily. In that case, a full evaluation is the more honest path, not a patch. Where it genuinely shines is on systems roughly 7 to 14 years old that run fine once started, but show startup symptoms, or newer systems in homes with weaker incoming voltage or long wiring runs to the outdoor unit. And this is not a DIY electrical project. It involves working inside a high voltage panel, and it belongs in the hands of a licensed technician. That's the whole story, and it's a good example of the kind of thing we dig into here at Hidden Fix Lab. Not miracle fixes, just practical, honestly explained solutions that quietly save you from bigger problems down the road. Next time your AC kicks on, take 15 seconds and actually watch your lights. That one habit might be the difference between a $30 part and a $4,000 surprise.